Hello my friends, this is Vladimir Pyntia, FAF091 CPC Update. Today I would like to speak with you about podcast downloader. What is this? Basically, it is a simple program that extracts some podcasts audio files which it first filters out from an XML file. In our case, an RSS feed. The main joke about this my podcast downloader is that it is broken, basically because it was done far 2 or 3 months ago, and the main site where the RSS was taken from had changed. Basically, it now has a new look. The website, the whole website, and its RSS feed. So, first of all, what would I like to mention? That in order to take out some information we need, we can do it in 2 steps. First of all, receive actually the RSS feed in a file, and then extract from an XML, which basically has a representation something like some tags written in a tree, which we have to specify and extract data. This is like head, and here we have, for example, audio. How can we do it? And a closed tag. How can we do it? Basically, it is done using regular expressions and some nice library which is a part of LXML library, but I don't know why it didn't work on my PC, so I just used libxml2, which is also very powerful tool. So, and what did we? We defined our host, we defined our port, then we specified the HTTP request, which was get the host, actually the domain where we can find it at that host, and gained an answer, which actually was the RSS feed with some headers. In our case, there was a big problem with the headers because basically first time when I received the header, it was something like I received the whole file. Here it should be. So in such a way we received the whole file, which is the podcast XML. Actually, we receive an answer with the whole file in it, which has a header, 200 OK. Then we receive what kind of content it is, when the session expires, and some information. And in the payload, actually, there is the XML file, which is the actual RSS feed. So, what should we do? First of all, we should split these two, and in such a way we get the basic XML, which is the RSS feed. It has a lot of tags. It's a standard tree. We can see it like the main, then some other, then cdata. Somewhere in all this file, our information is hidden. Basically, it's hidden in these fields: media content, type of the media content, size the URL of the media content where we can get this. So what should we do? We should extract this information from that file. Also, some other fields are interesting to us. It is the name, the first name or something like that. Basically, the old XML had fields of media which were specified like title and author, something like that, and I extracted that fields. Okay, I can show you it from the actual source code. Okay, in the first part we receive actually the RSS feed. We save it in a file, then we try to split up the header and receive it into a podcast XML in order to parse it using libxml2 parse file. Then we specify we had to register a new path, basically because there are some predefined XML paths, tags that it can reach, but when we need to reach some special tags which are not defined, we should redefine them. I found the source for media, which was from search.yahoo.com mRSS, media RSS, and then we should define some functions: get titles, get keywords, and get URLs, which returned us the information we need, which was specified in title content. For title, it's like an iterator using XPath evaluation. For tag item, which is a higher level tag, then media, and the special media tag, which was title. In such a way we parsed also keywords for these podcasts and the actual content with an URL. In the field content, media content, then it was at URL tag. It is not a tag, it is like a special argument, which is like this, URL. So we found media content, then we pass to URL. So what do we do next? Next, we store this information in lists. We iterate through them and show up this information. Very nice. URLs and so on. Show up this information in range of I. From titles, get info. We parse titles and just arrange all the data as we need. So actually, when first time I tried to download to a file, actually get a podcast file, it is an actual MP3 file, I had some troubles. Mainly because when I tried to get this file using a simple HTTP request, not HTML, HTTP request, to the address 1, which I split it off from the basic URL. I should split it from HTTP, then split it from another pieces I didn't actually need, to the address from the main host. I get some problems, and one of them was 302 found, which actually means that this document has moved, and it gives me the new location from a mirror web server where actually this file moved. And the trouble was that I had to reparse all this information from HTML I received from an HTML document, and it was funny because for some links it didn't give me this response like redirection. For other, it gave me like 2 or 3 times this kind of response. So I had to redefine some new functions, get new location, where actually used some regular expressions on this pattern to find out the location. Actually, from the header, it's the location of a new file, and then try to get the actual file also by splitting the all unnecessary information like HTTP. Then I split up the mirror blip TV. Then I split up the actual name of the file in order to get it to write a nice, beautiful get HTTP request. So when I got the new MP3 location, I had to get to run a nice HTTP request in order to receive the file. But in order to write a nice HTTP request, like get the location of the file to the server, HTTP version 1.1 host, and the location of the file, I also had to specify an additional field, which was the content length, because I wanted to receive only the length I needed, and also in case that somehow this session was interrupted, I needed to resume it. But in order to resume it, I shall know the actual range for the length I want to start to receive bytes again. So in this way I found out all the necessary information I needed, the dimension, the location, the new location. Then I generate my request with all information I needed, and in such a way I received the file, which I could eventually structure, like save it, manipulate it any way I need it in a temporary file, of course. And okay, now I would like to mention how did the resume work. Actually, when I make an HTTP request to get the file, first of all I need to verify if already some files were extracted. In this way I created the temp file, the temporary empty file, or in case there are some bytes, I had to get its size, and from the last byte where the size was mentioned to write a new HTTP request to save the location. As I had all the MP3 location, all the names stored in a list, I had only write a new request, range of bytes, which was called range of bytes, add a new field in my header, in my request, which was in range of bytes and the byte where to start from. It was possible mainly because I used HTTP 1.1, and in such way I received the file. In this while loop I received the new file, which was defined like a buffer, length of buffer, floating, yes, and also I implemented a very interesting feature, which is somehow the progress bar. But it wasn't a bar, it was just a nice percentage which showed up in line using this sysstdout_write with some backspaces in order to show a nice percentage progression from with the 2 digits after the dot. And then I appended all the bytes I received, newly received, write them to the temporary file, and when there was no buffer to receive, then when actually there was nothing to receive more, I generated my MP3. I was generating my MP3 file, renaming the temporary in .mp3 with the name of the file, and in such way I finished to receive all the information I needed. In the console, I just showed up all the information each time I needed, and then I closed all the sockets opened before actually. So the main ideas were receive an answer with a payload of XML, then split the answer into an XML file, then parse the XML file in order to receive a file, in order to receive all the information I needed, yes, to receive all the information I needed, even if I received a 302 response that the file was found but it actually moved. Reparse this HTML using regular expressions, and then write a nice HTTP request to the new location. In case that somehow the transmission was interrupted, get size of the temporary file, store it in a dimension of bytes, and write a new request using this value of bytes, range of bytes, HTTP 1.1 request, and save this new information you received in a file, renamed, append all the information received in chunks, append it to the new file, then rename the file, and here we are, the MP3 file, which actually we can play. You can listen for it.
Independent Jazz with your host Renato.
Some nice old school jazz. Thank you very much. This was my screencast on laboratory work number 2. I hope it will help someone in his studies.